This video will help you to know about electrophilic substitution reaction. First step is generation of electrophile denoted by E+. Electrophiles are CH3+, CH3CO+, NO2+, Cl+, SO3, etc. When CH3Cl is treated with anhydrous aluminum chloride, this Cl with these two electrons and LCl3 form AlCl4 minus, and this CH3 becomes CH3 plus. You see, this is CH3 Cl. Between these two atoms there are two electrons. This is the electron of this carbon, this is the electron of this chlorine. AlCl3 has electron deficient center. Al has 3 electrons. 3 chlorine atoms provided 3 electrons. Now Al has 1, 2, 3, 4, 5, 6 electrons. To attain octet, it needs another 2 electrons. This Cl with these 2 electrons can form a bond with this LCl3. This is Cl minus LCl3 becomes LCl4 minus. CH3 group becomes CH3 plus because this electron is lost by this group, or this electron of this carbon is lost. So CH3 becomes CH3 plus and this LCl3 becomes LCl4 minus. In this model, the C and Cl are bonded by a single bond. This electron belongs to this carbon and this electron belongs to this chlorine atom. This is brown colored, this is red colored. Now CH3Cl will be treated with a halogen carrier, that is the catalyst in this reaction. In LCl3 you find Al has 3 electrons and each chlorine will provide 1 electron to this aluminum to attain sextet, means 6 electrons. You see, this chlorine will provide 1 electron, this chlorine will provide 1 electron, this chlorine will provide 1 electron. Then what happens? Being electron deficient, it needs another 2 electrons to attain its octet. LCl3 can accept this chlorine with these 2 electrons to attain octet. You see, these 2 electrons, this chlorine and LCl3 will become LCl4 minus. You see, this CH3 will become CH3 plus and this Cl becomes Cl minus. LCl3 and Cl minus becomes LCl4 minus. This CH3 becomes CH3 plus and this LCl3 and Cl minus becomes LCl4 minus. This CH3 becomes CH3 plus and LCl3 becomes LCl4 minus. Formation of sigma complex or carbocation. This pi bond will form a sigma bond with CH3 plus and this carbon will gain positive charge. If this bond contains these 2 electrons, these are 2 sheets, and this will be forming this pair will be forming a bond with this CH3 plus, and this carbon atom will gain a positive charge, and this CH is connected to this carbon becomes sp3 hybridized. This is the carbocation form. Let us draw different resonating structures of this carbocation so formed. This carbocation has lost its aromatic character because this carbon is sp3 hybridized and rest 5 carbon atoms are sp2 hybridized, but its other resonating structures can be drawn. Let us draw other resonating structures of this carbocation so formed. It has lost its aromatic character because this carbon is sp3 hybridized and rest 5 carbon atoms are sp2 hybridized. This pi bond will be shifted to this side, and this carbon will get positive charge because this carbon will lose this electron. As this carbon will lose this electron, it will gain positive charge, and that can be shown in the next resonating structure. You see, in the next resonating structure, this double bond is shifted to this side and this carbon gained positive charge. Similarly, third resonating structure can also be drawn. You see, the third resonating structure is drawn over here, and this double bond shifted to this side. There are 3 resonating structures for this carbocation. Let us draw the resonance hybrid of these resonating structures. This is the resonance hybrid. Positive charge is present in the middle of the ring, and this resonance hybrid of this sigma complex will lose this H because this is an acidic hydrogen. When this H atom will be lost by this sigma complex or by the resonance hybrid, it will lose its electron, and this can be taken by this positive charge present in the middle. It is possible in presence of LCl4 minus. You see, this H plus will take Cl minus from LCl4 minus becomes HCl. LCl3 is regenerated because it is the catalyst. This is the halogen carrier, and the product is toluene. CH3 group is connected to this benzene ring by substituting one hydrogen atom. This is toluene, and in this case the electrophile is CH3 plus. This reaction is popularly known as electrophilic substitution reaction, and name of this reaction is Friedel-Crafts alkylation. Similarly, in other electrophilic substitution reactions, the electrophiles are CH3CO plus, NO2 plus, Br plus, SO3. In sulfonation, the electrophile is SO3. In bromination, the electrophile is Br plus. In chlorination, the electrophile is Cl plus. In acylation, Friedel-Crafts acylation, the electrophile is CH3CO plus. Now we'll do the reaction in a simpler method. You see, when benzene is treated with methyl chloride in presence of anhydrous aluminum chloride, the product will be toluene and HCl. This H will take this Cl from methyl chloride, and this CH3 will be connected to this carbon. and LCl3 is the halogen carrier, and the products are toluene and HCl, and this is anhydrous aluminum chloride. Thank you.